Jai Hind students. After discussing various satellite communication basics, we are now going towards the various application of satellite communication. In the last lecture, we studied about VSAT application, means very small aperture terminal, and that VSAT came into the picture because we want to access the data at remote location through the satellite communication, and to accessing any data from satellite you have to establish a earth station. Earth station construction is a quite complex job. That's why for small users where the antenna size is less than 1 meter, that VSAT came into the picture, and VSAT stand for that very small aperture terminal. Now, by using that same DBS, the same VSAT technology, the next generation television transmission came into the picture, that you all know as DTH, direct to home service. That DTH is basically coming from the DBS TV, means direct broadcast satellite television. So when you are talking about that DBS TV, its basic structure having a uplink earth station with a geo satellite that is using for the direct broadcast TV geo satellite, using the same C, KU or KA bands for the uplink and downlink. And the individual home DBS TV receivers are having VSATs, and that VSATs are going to use to access the data from the satellite directly. In the current scenario, this technology is widely helping the nation, as in the previous one, when the cable operators are in the picture, if any area government want to put a ban on the transmission of the television or the news, in that case they are using a normal notice, and then cable operators are going to shut down. In any case, if cable operator is not shutting down that shutting out its instrument, in that case TV transmission is going on. But now, after coming this DBS TV concept or direct to home concept, easily government can directly stop the transmission at the uplink earth station, so that information cannot be spread out in the various places, because now you are accessing the data directly from the uplink earth station through the satellite. There is no any cable operator between it. So these are some basic advantages of DBS TV. Now this is the simplified structure with the various blocks that are used by the DBS TV. You can see that this is the station part, which is located at uplink earth station or gateway uplink earth station. Means here you are getting the video, audio or data, means video data, audio data or data, means that data is actually related to that some internet access type concept signals. So what is having, actually in DBS TV concept, you are using MPEG format. That MPEG coding system is used to encode the data of BAD, means you are going to multiplex all of 3 datas with the MPEG coding scheme. Then that data is going to the framing header of forward error correction. Then you are using a QPSK or PSK technique for the modulation purpose, which is creating a intermediate frequency that is applied to a up converter with a low power amplifier and combination of a low power and high power amplifier combination, that is combinedly making a up converter. Then a wide more than 10 meter diameter antenna, that data is going towards the satellite on uplink frequency of 17.2 to 17.7 gigahertz. This is a GEO DBS TV satellite that is working on the downlink frequency of 12.2 to 12.7 gigahertz, means that is the downlink frequency, where a VSAT is applied, that is a home satellite TV receiving system with low noise LNB. So what is that LNB? I am going to discuss in the next slides. Again, that is producing a intermediate frequency, means this is the outdoor unit, this is the indoor unit, same as the VSAT. Here demodulation QPSK, because you are using QPSK here. Then forward error correction decoding. After that you are decoding the information by MPG decoding of baseband demultiplexer, and you are extracting the data in the form of video, audio or data. So a complete microprocessor based approach or control system is there, or controller is there to control all that operation. So this is the simplified structure of a direct broadcast satellite television system. Then you can also understand it that VAD bit stream are compressed using MPG2 or MPG4 compression techniques and formed into packets and frames, means that complete system is digital. Also, forward error correction and modulation method can be changed on command by the control lines. Data stream is also encrypted to prevent the unauthorized access, means you can control the transmission for the specific user. Then the modulated signal is sent to the transmitter at the intermediate frequency of 700 MHz. So that home receiver uses a low noise block converter to down convert the received signal to intermediate frequency and send them to the satellite receiver, which reverses the operation carried out in the transmitter. So that low noise block is basically just reverse process of this up converter. Then these are the DBS TV receiver. The first part of the DBS TV receiver is actually this antenna part. So this is the basic DBS TV receiver antennas. You can see that this is the parabolic part, this is the feeder or receiver part. That feeder or receiver part is actually made by a waveguide type structure, because microwave frequency is going to be used. That is basically act as a primary antenna in that structure, and this one is the secondary. And then as per the antenna characteristic and antenna procedure, that both things are going to be taken out. Then this is the DBS TV receiver basic structure. That is actually the, which one part is the outdoor unit. Outdoor unit that is located on the roof. Here you can see that this is the waveguide structure. Here there is a corrugated waveguide horn. That horn is actually using this low noise amplifier and getting this orthogonal waveguide probes for vertical and horizontal polarization. So that is basically used for the beam structure, as I told you in the previous one, that phased array antenna with the polarization vertical or horizontal that are going to be used. So low noise amplifier 1 is actually applying the polarization part, and that polarization control is governed by this RF radio frequency block. Then there is a coupler which is combining these both orthogonal waveguide probes through that polarized data in the one stream, and that one stream is applied here for the BPF band pass filter for the image rejection. Actually unwanted noise, that is also creating a image rejection here. Then low noise amplifier 3 with a mixer, and because you are creating a intermediate frequency for the system, that's why a low noise amplifier, local oscillator with a 11.3 gigahertz frequency, and that is creating a 900 to 1400 megahertz intermediate frequency, which is going to be sent to the next part of this structure, that is indoor unit. Then a coaxial cable to the indoor unit. So when you are talking about this, some technical specification is also there, and that are a single channel KU band low noise block diagram is used for the satellite reception, that is this one KU band. Input is two circularly polarized signal in the 12.2 to 12.7 gigahertz band, that are this one V and H. The polarizer plate convert the left hand circularly polarized signal to a vertical E field, linearly polarized wave, and right hand circularly polarized signal to an H field wave. So for E field you are using a vertical, horizontal for the H field. Similarly, the orthogonal probes in the circular waveguide extract the V and H polarized wave and fed into two LNAs. These are the two LNA1 and 2, LNA1, LNA2. Then the RF block is an inductor to prevent the intermediate signal to enter into the polarization line, because this is the polarization side, that is also here. So this is the technical specification of this part. After that, this is the set-top box. You all are very familiar with this word, because everyone having a set-top box at their home, because without set-top box you cannot receive any type of data into your TV right now. So that coaxial cable is coming from the antenna and the low noise block. Now you are having a intermediate frequency amplifier with a band pass filter to tuned BPF to select transponder. So here you can see that this is the band pass filter, and that multiplexer is actually that all is converting from the microprocessor based system, in which there is a frequency synthesizer, also there is a tuned local oscillator, that all combinedly using for this system. Then a SRRC band pass filter with the 70 megahertz intermediate frequency amplifier, where you are using QPSK demodulation method. Then a baseband signal is recovered here, so a baseband amplifier, and after that a baseband processing, which is giving you the video, audio, data output to the TV sets. So basically this is the set-top box structure, where you are actually decoding the signal through the intermediate frequency signal, where a microprocessor based controller is used to control the complete operation. And this is the master control station, because in the DBS TV, as starting from here, you can see that this is the sending part, this is the receiving part. In receiving part, here is the low noise block with the VSET. In indoor part, you are having the set-top box. But this uplink earth station part is still we have to discuss, and that is master control station. So when we are talking about this master control station, what is here? You are having select header. Basically, that header part is coming here for the digital part, digital encoding part, which is having the forward error correction encoder with a scrambler. Also, the VAD data, that video, audio and data, is coming in MPG packet through the MPG encoder, and here we are using MPG2 or MPG4 compression techniques. Then the buffer is applied here to maintain the synchronization. After that, forward error correction with the select FFC code rate. Both scrambler are going to scramble the data into a single frame, and a complete frame is going to be created at this end with the VAD data. So means this complete block is actually used to creating the combined frame using MPG data compression techniques with video, audio and data signals. Then that packet frame is applied to the 70 megahertz PSK modulator, or select QPSK or 8 PSK, means you can use QPSK or that's when you are not related with the spectrum efficiency part, you can use this PSK also. So then SRRC band pass filter, then a up converter, and after up converter there is a 1700 megahertz intermediate frequency. For that is a up converter with a combination of low power amplifier and a high power amplifier, and that data is given to the uplink antennas. So technically the upper block of the diagram are the baseband, the frame that are sent to the PSK modulator depend on the signal format. Then the buffer assemble 8 or 32 MPG packets to form short or long frames and apply a double layer of forward error correction coding. Then the scrambler that multiply the encoded data stream by a pseudo random sequence to provide energy dispersal. Actually, that scrambler is creating the pseudo noise, also known as PN code, PN coding, that is actually required to provide the energy dispersal. So in this example, this is the previous one, 70 MHz PSK modulator can operate in QPSK or 8 PSK mode and followed by a SRRC band pass filter. Then that SRRC filter must be a digital finite impulse response filter to match the bandwidth of the QPSK or 8 PSK signal. So the PSK signals are upconverted to 7 MHz and sent to the transmitting antenna. So this is combinedly creating a DBS TV system, and here you can easily understand that this complete data, how it is going to be happen. So whenever you are talking about the digital direct broadcast satellite TV system, you are actually having various points which you have to discuss. That points are, first one, it is sending all three of data types on a single frame, that is MPG packet. That MPG packet coming from the MPG2 or MPG4 compression technique. Also they are using a intermediate frequency of 700 MHz in this particular example, so that they can design the complete system for that frequency range. Also the one point is here that you are using a combination of polarization, because you are using actually circular repolarization with vertical and horizontal plane, because left hand circularly polarized and right hand circularly polarized. KU band for the low noise, KU band used for the DBS TV receiver. So combinedly there are various aspects of DBS TV. You all have to remember these all technical specification of DBS TV, as these are asked in the 2 marks question, such as there is a question, which band is used by the DBS TV? So that answer is KU band. Or they can use which type of transponder used by the satellite for the DBS TV? That is a double converter transponder, because that is actually a 16 to 14 gigahertz double conversion transponder. So these all are the technical specification of this direct to home technique. In the next lecture, we are actually going to discuss about the next part of this, in which we will discuss how a satellite going to be launched in the space. And also we will discuss the another application of satellite, which is also very important, that is used for the navigation purpose, that is GPS. So till then, thank you.